We also have a Green's theorem area formula. And I don't know that it's necessarily important for you to have this memorized, but I do think it's important that you know it's a formula which you could utilize. This comes from our flux or divergence form for Green's theorem. So let's just use this in an example. In this example, we're going to find the area of an ellipse, and the ellipse is defined parametrically by the vector a cosine ti plus b sine tj, and t falls between 0 and 2 pi to get that full rotation. So by definition, x represents my m value and y represents my n value, or like this. So we know that m is equal to x and n is equal to y. Now I don't need to include that negative with my y because the negative is already part of my flux or divergence Green's theorem formula. So here we just need to state x in terms of t and y in terms of t. So m is actually equal to a cosine t, whereas y is equal to b sine t. And we can find dx. The derivative of cosine is negative sine, so I have negative a sine t dt. And dy, the derivative of sine is cosine, so b cosine t dt. Therefore, rewriting what we have up here, this line integral is going to be the integral from 0 to 2 pi x times dy minus y times dx, or 1/2, again, the integral from 0 to 2 pi. My x value is a cosine t, and we have that times dy, which is b cosine t. Technically a dt there, but we'll factor both of those out. Minus y, which is b sine t, times dx, which is negative, 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 that will be positive. And we'll have a sine t. And then all of this, we have our dt there. So this simplifies because I actually have cosine squared plus sine squared. So here we have 1/2, the integral from 0 to 2 pi of ab cosine squared t plus ab sine squared t dt. So a and b are constants. I'm going to factor those out. I'll have ab over 2. Cosine squared plus sine squared is 1. So now I have ab over 2, the integral from 0 to 2 pi dt, or ab over 2, that's going to become t, evaluated from t equals 2 pi to t equals 0. Plugging in 2 pi and 0, we get 2 pi. 2 pi ab over 2 is just pi ab. That is the area of the ellipse, pi times a times b, a and b being coefficients. Now, if this ellipse had been a circle of radius 1, then a and b would be the same for a circle. And a circle of radius 1, that area, 1 times 1, we would get pi, pi r squared, pi times 1 squared. So this makes sense for an ellipse. It's the product of the radius in a sense, but it's not a radius, but the half the length of the major and minor axis, if you will. So again, in this video, we defined a new formula that is available for us to use, which is derived from the flux divergence form of Green's theorem.